Good morning, class. This is week 12 of our natural disasters class. This week we're going to be talking about hurricanes and extratropical cyclones. So this is sort of a continuation of the last chapter, which was about severe weather and atmospheric processes. So cyclones, tropical and extratropical cyclones, are really just basically one of the major disasters that can happen from severe weather. And so the people who wrote the book just put more importance to these since it's a little bit more complex than, just a couple pages. So we're going to go through them. It shouldn't take too long, but it is a fun chapter. So make sure you pay attention to it. All right, so this picture that you're seeing here is pretty much of a basic tropical cyclone, also called the hurricane here in the northern hemisphere near the North American, or the Americas, I guess I should say. As you're seeing there, it's rotating which way? Okay, hopefully you said counterclockwise. So it's rotating counterclockwise. That's going to happen for any cyclone in the northern hemisphere, and then they're going to rotate clockwise whenever they are occurring in the southern hemisphere, which is pretty cool. This is not particularly a big cyclone. This is a pretty average one in terms of diameter. You'll see later on, but usually they get to be somewhere between 500 and 600 miles in diameter. So this is a pretty regular one. At the beginning of the chapter in your book, you'll see a case study kind of the Superstorm Sandy that happened in 2012. So you might have followed the news on Superstorm Sandy, which before it made land, it was a hurricane. Superstorm Sandy was actually 1,800 kilometers in diameter, so it was almost 3 times as big as the average hurricane, which is just insane. Superstorm Sandy, although when it made landfall, it was no longer a hurricane. It didn't have as much wind speed as it did when it was in the ocean. It still was very costly because it was still, very, not incredibly high winds, but still pretty high. It made a lot of rainfall, and with it came a storm surge. So with all these things, it still cost the U.S. Government 71, or the overall, not just the government, but also the people, the private parties, $71 billion in damages. So 71 billion for one storm. It's pretty amazing. So this is only the second most costly cyclone damage, second to Katrina, as you might have known. So Katrina again happened in New Orleans, 2005. We'll talk about it a little bit more later. So Irene and Sandy, if you know about Irene too, caused flooding to New York in the 21st century. And as we have seen in the past 2 decades or so, more and more damage will come to those lower coastal elevations as the sea level is rising due to the melting of the glaciers. And not only the sea level rising, but perhaps some subsiding. As you guys saw, for example, in New Orleans, the city itself, it's subsiding a little bit, which doesn't help the overall sea level at the city. So all of these things put into perspective make us, beware of the overall hazard that we have as humans of these major cyclones. So again, pay attention to the chapter as we go along. Right, so a cyclone, the definition of it, is going to be an area or center of low atmospheric pressure characterized by rotating wind. So if you think about some of the storms that we had seen in the previous chapter, they were also classified as cyclones. So within the realm of cyclones, things such as hurricanes, typhoons, extratropical cyclones, even actually tornadoes do classify as being a cyclone itself, just based on that first definition that I have, right? Okay, so these cyclones, because of the Coriolis effect that we saw on the last chapter, are going to rotate again counterclockwise in the northern hemisphere. They're going to be deflected to the right? And then they're going to rotate clockwise or be deflected to the left in the southern hemisphere. Okay? All right, so there are 2 main types of cyclones. We have tropical cyclones and we have extratropical cyclones. The picture that you guys have on the middle right here, that's going to be a tropical cyclone. And then the one that we have over in the bottom is going to be an extratropical cyclone. So the tropical cyclones usually occur or start forming in latitudes 5 to 20, so pretty close to the tropics, but not quite at the tropics, because you still need some Coriolis effect, some Coriolis force, in order for them to form. If they were at the equator, right, then they would have basically no Coriolis force. So they still need some, so they're still in the tropics, not quite at the equator. So they usually happen in those warm central zones that are not associated with fronts, okay? So there's really no change in warm front to cold front. It's usually still pretty nice and warm air masses. So within this tropical cyclones, things such as hurricanes, tropical depressions, tropical storms, tropical, what are they called? Dispersions are all included within the cyclones, okay? They cause usually high winds, heavy rain, surges of the rising seawater, so those are basically storm surges as we'll see them later, and also tornadoes if they are, kind of like the end of the tropical or any storm as we had seen in the previous chapter, right? Okay. And then the extratropical cyclones, they usually happen at higher elevations, so somewhere between 30 degrees and 70 degrees in latitude. They usually are associated with fronts, so they're going to have cool central zones. So if you guys remember from last chapter, we had cold fronts, warm fronts, occluded fronts, and then stationary fronts, right? So extratropical cyclones tend to be associated more with cool fronts, warm fronts, and stationary fronts. But the most common ones are cool fronts. Okay. So when they happen as storms, they're going to cause windstorms, heavy rains, also surges in rising seawater, depending on where they happen. Usually this is going to be on the west and east coasts during warmer months. And then they're also going to cause snowstorms and blizzards during the colder months. They usually tend to be pretty big players in causing the tornadoes and the severe thunderstorms whenever they happen, in the middle area of continents, not near the sea, but rather, in the big plains, for example. They tend to be one of the bigger causes of these tornadoes that happen in the supercell storms, right? Okay. So the cyclone intensity, as you're seeing there, is going to be the characterization of a cyclone. So it's going to be based on wind speeds and based on the lowest atmospheric pressure that is felt in the cyclone overall. So this system of classification is often debated, and it is based on science, politics, and also different customs of different cultures. So it varies also, globally. So for example, the cyclone naming kind of procedure, as you may have been aware of, how some hurricanes are called, or we start calling them from A through Z during the year as they happen, and also they alternate between female and male names. That system started only since the 1940s. And I should say that system only happens in those cyclones that are more intense and also those that are tropical. So it doesn't happen for extratropical cyclones, only for those that are tropical cyclones, and it only happens for those that are, have high intensity. So they have to be bigger than a tropical storm. Okay. All right, so the classification of cyclones themselves. So as I was saying, many different names are given basically to the same process. So for example, the nor'easters is a type of extratropical cyclone that is given to northward tracking cyclones in the east coast. Hurricanes are going to be basically tropical cyclones that happen in the Atlantic and the eastern Pacific Oceans. Typhoons are going to be basically the same thing as hurricanes. They're going to be tropical cyclones that happen in the western Pacific Ocean, west of the 180th meridian, and north of the equator. So basically, a hurricane happens in, North America. If it were to happen in South America, it would. and then close to the western part of, or the west coast, I should say, of North America. However, a typhoon is going to happen mostly in Asia, okay? All right, and then kind of like, it's a funny word, it's a cyclone variation word, but your book doesn't really describe it very well. But the cyclone variation kind of name is going to be given to those that occur in the Western Pacific south of the equator. So those would be things that hit, for example, Australia, like the Oceania kind of realm. So for simplicity and not to get confused with all the names, all of these tropical cyclones, so all of these guys that I named except the nor'easters, are going to be referred to as hurricanes for the rest of the chapter, okay? So I'm going to lump together hurricanes, typhoons, and that cyclone variation name that is given to those that occur in Oceania, okay? All right. So when we talk about classifying them based on the wind speed, there are 5 main categories. So as you're seeing there, the first one is going to be the lowest wind speeds, and then the highest one is going to have the highest wind speed. So 5 is going to be more dangerous than 1 overall. So 1 being the minimum damage caused and the lowest wind speeds, and then 5 being the most damage caused and the highest wind speeds. So that's nothing too crazy for you guys. So this is based on the Herbert Saffer and Robert Simpson scale, a potential scale that was given. So that scale is in your table, in your book, in table 1 described. I recommend you check it out. It's pretty good. I didn't put it there because it was very detailed, but in there it gives you not just how much how much wind is related to it, but also what the atmospheric pressures that are related to the specific hurricane category are, and also what kind of damages you expect to see happen when one of these massive cyclones occurs. Okay. So this category, so going from 1 to 5, will almost always change during the life of the cyclone, meaning the cyclone can start being a tropical storm, and then it can jump to being a first category hurricane, then maybe go all the way to being a category 4 hurricane, for example, and then once it makes landfall, it might be a category 2 hurricane. So it can jump back and forth from higher categories to lower categories, depending on how much warm air mass it's having, how much wind speed, like how great the wind speeds within it are, and how much resistance is put to the cyclone itself. All of these things are going to affect whether or not it stays at a specific category, or it grows, or it diminishes. Okay, so category 5 usually has a central atmospheric pressure that is lower than 920 millibars, just so you know. So if you guys remember the lab that you did for last week, and you had to do that, isobar mapping, you saw that most of the millibars that were in that map were somewhere between what was it? I think it was 1100 and 1400 or so. So as you're seeing there, the category 5 hurricanes usually have a central atmospheric pressure that is lower than 920 millibars. I think later on in the presentation, we'll see a couple of examples that got to atmospheric pressures that were 800 or 850 millibars, which is very, very low. So again, the higher the category, the higher the wind speed, and the lower the atmospheric pressure in the central zone of the cyclone, okay?